Hi everyone, we are in Chapter 5 now, working with measurement numbers and unit conversions. So we're going to talk about significant digits, and when we talk about those, it has to do with actual measurement, because when you look at a measurement number, significant digits can tell you how accurate it is, where it was rounded to basically, and it's going to have to do with the significant digits in the number, in the measurement. Okay, so these are rules for significant digits. How do we know how many digits are significant when we're looking at a measurement number? All right, rule number 1, digits other than 0 are always significant. So if it's not 0, it's significant for sure. Rule number 2, a 0 is significant when it appears between two significant digits. So if it's between two numbers that are not zeros, it's significant. It's at the right end of a decimal number, or it's marked as significant with an overbar, so you have a little bar on top of the 0. A 0 is not significant when it is at the right end of a whole number or the left end of a number. Now, I want you to keep these in front of you, these rules, as we go through trying to figure out how many significant digits are in the numbers in the chart following this, because that way you can refer back, but I'm going to kind of remind you. Also, you may want to pause the video and just see if you can list how many digits, significant digits, are in each of these measurement numbers. So I'm going to go through the first column and talk about each one briefly. So 4.06 pounds has 3 significant digits, the zeros between two numbers that are not 0, so that makes it significant. 24,000 is a whole number and it has a bunch of zeros after the 24, so there are only 2 significant digits in that number, in that measurement. That's meters. 17.540 seconds actually has 5 significant digits. All of them are significant, and this 0 is at the right of a decimal number, so that makes it significant. That's basically saying that this measurement is accurate to the thousandths place, right? We were able to measure it that way. Volt, the 0.004 volt, has 1 significant digit because the zeros in front of the 4 are not significant. And then 14,800 gallons, but we have an overbar on one of the zeros but not the other one, so this one would have 4. And then 500.0 would also have 4. All those zeros are significant because they're following the 5, and it ends after the decimal, so we count them all. Now pause this and see if you can do the next column and then come back in, and you'll be able to hear what I have to say with all of these. Next, 68.5 has 3 because none of them are zeros, so they're all significant. The next one has 4 because the zeros between other digits. This one has 2. 480 volts, and then 480 with an overbar has 3. That's just basically saying this one is significant to the tens place, and this one is significant to the ones place, right? Because of the overbar. It has to do with being the accuracy of the measurement. And then the next one is 2 significant digits because the zeros in front are not significant. And then the last one is 3. Okay. Next column. So this one only has 2 significant digits, all the way out there to the thousandths, 10,000, the hundred thousandths place. The next one is 3. 0.0708 is 4, which of that is 708 10,000ths. This next one has, wait, no, that's not 4. That one's 3. I'm sorry. This 0 is not significant. And then the next one is 4 because only this one is not significant. And then 2. And last we have 3. All right. So that's just a little bit of practice with that, and you might just think about that as you go. How do I identify the number of significant digits, and practice it, because otherwise you'll just forget what all of these meant, all of these rules, right? Precision, accuracy, and greatest possible error. The precision of a measurement number is indicated by the place value of its rightmost significant digit. So that's about precision. So if the right digit's in the tenths place, it's precise to the tenths place. And if it's in the hundredths place, it's precise to the hundredths place. And, we're talking about significant digits. So that part matters when you're looking at these. So you're looking for the number to the right, and it's, that's a significant digit, meaning it might not be a 0. And the accuracy of a measurement number refers to the number of significant digits that it contains, so how many significant digits are in the number. And then greatest possible error of a measurement is defined as half the precision of that measurement. So if the measurement is precise to the tens place, then half of that would be 5. We would add or subtract 5 from that number to find where our error might lay. Because when you're measuring things, it's hard to be completely accurate. So you can only be so accurate, and that's what that's telling. We could be off, right? We could have an error in our measurement. I'll give you some examples of each one of these with precision. So on this one it says tool consistently can measure to a certain place. So in other words, in this case it can measure to the tenths place. The number that's on the right for significant digits is the 6, so it's precise to the tenths place for that reason. And then let's look at the greatest possible error, because on it, we're looking at the fact that this goes to the tenths place. We're going to take half of that to determine how far off we might be, and that's plus or minus 0.05 because it's the tenths place. So if I take 0.1 and I divide it by 2, I get 0.05. And that simply means I can subtract that from 14.6. Minus 0.05 is 14.55. Or I can add it to 14.6. And that gives me 14.65. So if you think about in measurement, let's say that we're looking at a ruler, and the little marks, a lot of times when you're measuring, it's in between them, so you go to the one that's closest, and that's what this is talking about. We could be off by half the distance either way from this number, and that's where we came up with this 0.05. On accuracy, the closeness of the measurement to the true value, and we look at that with the number of significant digits. So we say this number is accurate to 3 significant digits, right? 14.6 centimeters. Here's where we're going to practice this. Okay. So as we look at this, we see that we have 4.01 seconds, and that is precise to the nearest hundredth of a second. Now you have to talk about seconds here because we are talking about the nearest hundredth of a second. The number of significant digits is accurate to 3. And then my greatest possible error is going to be half of 1/100th. So if you take 0.01 and you divide it by 2, you're going to get 0.005. Notice we go out one past that basically. But if you'll just put this on your calculator and look at it, that might help you understand the hundredths place, 1/100th. And it doesn't matter what number is in this place. We're just talking about 1/100th. We divide it by 2, and then we're able to get our possible error, our greatest possible error. Now, this is the digit that is significant on this number. It's in the tens place, so this is precise to the nearest 10 seconds. And it has one significant digit. Half of 10 is 5, so it's plus or minus 5 seconds. I have room for that. I'll just write it out. This next one is to the tenth, the nearest tenth of a second. It has 4 significant digits, and then it's plus or minus 0.05 because it's half of 1/10, which we talked about on the previous slide. 0.568 is precise to the nearest thousandth of a pound. Notice we changed measurement here. Thousandth, if only I could say that, thousandth of a pound. This one has 3 significant digits. Now, we're taking half of 0.001 on this one for our greatest possible error, so it's plus or minus 0.0005. Notice we are out 1 digit further whenever we name our possible error there. 34.00 pounds. We are precise to the nearest hundredth of a pound. It has 4 significant digits, and it will be plus or minus 0.005. Whoops, I haven't been putting those pounds on there. I better do that because that's important to have that there. All right, here's our next one. So this is to the ones place, so we're just going to say to the nearest pound. It's precise to the nearest pound. And it has 4 significant digits. Half a pound would be 0.5. So that's our greatest possible error. And then 500 feet. This is our digit that is furthest right that is significant. So this one is to the nearest, precise to the nearest 100 feet. It has 1 significant digit, and half of 100 is 50. So plus or minus 50 feet on this one. And that's just because that one's not very accurate as it is. It's only accurate to 1 significant digit. Okay. When we're adding and subtracting, and try not to get too bogged down in this, a lot of times you can tell within the problem how to round your answers, and this is giving you some guidance on that. If you're adding and subtracting, you round answers to agree in precision with the least precise measurement number. All right, and so when we're looking at this next one, what is the least precise measurement number on this one? If you take a look at it, you will see that we have hold on, I'm getting tongue-tied here, just one moment. The least precise is to the tenths place, and so we round this to the tenths place. So you have to look at what's precise when we're adding and subtracting. When we're multiplying and dividing, we are going to round answers to the same number of significant digits as the least accurate number in the calculation. So when we're looking at these numbers, we can see that we are going to round to, right? We have 3 significant digits and we have 4 significant, so we're going to round to 3 significant digits. We probably need an overbar right here to show that we are rounding to 3 significant digits. All right, I'm going to stop the video here and we'll pick up on some of the other examples on the next video.